So today we're going to be talking about server name indication and why it's leaking things. So what is server name indication? Well, it's a TLS extension, and it was created back in 2003 to solve a very important problem. So in order to define that problem, let's look at what TLS kind of used to look like before SNI. So we have our client sending to the server, "Hi there, I support encryption." We have the server saying, "Awesome, so do I, here's my cert." And then we have the client who says, "Yeah, that works, let's do this." And then the client, now with encryption set up, can send the HTTP request for the site that they specifically want. So this is all fine and good when we have these, when it's one IP address to one server and you're doing TLS. But this gets a little more complicated when you start talking about things like hosting services. So how do you do hosting services when you are waiting until step, 4 to figure out what subdomain they're actually looking for? How do you provide the right cert? Well, early solutions included this. Your choices that you were faced with were either somehow get a very generic cert that covers everything that is hosted on your servers, or just don't provide TLS for your customers. And it's kind of a rough decision, a rough place to be in for those sites. So here's the inspiration for SNI. The creators of SNI looked at IMAP and SMTP and said, okay, well, how are we doing it here? Let's see if we can use that. So what the client does is the client says, I'd like to use the mail server at this specific domain, and the server says, cool, okay, by the way, I support TLS encryption, and the client's like, okay, yeah, start up the TLS, let's do this. I support this type of encryption, and the server says, here's my cert for that specific domain, let's use this algorithm. And the client says, sounds good, and starts sending messages. So our revised TLS handshake with that in mind becomes, hi, I support encryption, and I want to talk to this specific subdomain. And the server says, okay, here's my cert for that domain. Let's use this algorithm. Note that the server now knows in that first step what certificate it needs to provide to the client in order to establish that TLS connection. And the client agrees and then is able to send that request for their mildly shady page that they're going to. But the problem is, I don't know if you can see this, here's my client saying hello to the server and telling it what domain it needs a cert for. And as you can see, in the plain text of this hello, we have www.reddit.com. And if you look for the other TLS client hellos in this conversation that's going on, you can also see that I'm pulling up a media server connected to Reddit and numerous other things, because of course I have multiple tabs open at the same time. So this presents us with another problem. We have this thing that is very helpful and lets us have multiple sites per IP. But we're also kind of leaking some information. So what? Well, this is easy enough to capture over open Wi-Fi with Wireshark. Seriously, one of the most simple things in the world. There's a GUI and everything. Or if you're saying, but Steff, I use WPA2 everywhere I go. I am never on open Wi-Fi. Well, that's great. It's encrypted between you and your router. And then it goes on to your ISP, and it's once again visible. And with enough of these, if I sit there and connect enough of these to your IP address, I should be able to fingerprint you and figure out, maybe, who you are in real life. So, not really desirable. So, I have a story for you. So, there's an encrypted messaging app called Signal, and it's gained a fair amount of popularity. I don't know if it's as well known as WhatsApp, but it's fairly similar. So a couple of countries decided, you know what, we don't like our users using these encrypted services, so we're going to block everything going to Signal, and also, what else was there? I had a list here in my notes. Yeah, Tor, VPNs, several voice over IP applications, so FaceTime, and Apple's voice over IP client that I can't think of. Yeah, so these countries are censoring their users' access to private communications. And Signal, being the developers of Signal, being the clever people that they are, found a better way of doing it. There's a paper published in 2015 that talks about this, and the concept is known as domain fronting. So if we think about it, the domain that we're trying to talk to, that specific subdomain, shows up 3 places when we're doing our TLS connection. It shows up in the DNS request to get the IP of that server. It shows up in the SNI of that client hello, and it shows up in our HTTP request, which is inside of that encryption because we've already taken care of that by the time we get there. So what domain fronting does is it changes the server name indication on the client hello and the domain on the DNS to mask where we're really going. Those are going to say one thing, the allowed domain, and our HTTP request is going to say something else that's in a related subdomain that might not be allowed. And this makes it look like we're doing perfectly normal things that a censoring party wouldn't want to block, like checking our email on Google, or going to Amazon, or any number of other services of the sort. And the reason that it works is because the censor doesn't want to have the collateral damage of blocking all traffic going to all of Google's subdomains. If they blocked all of the sites that allow you to do domain fronting, they would be blocking most of the internet. And they would have a riot on their hands, essentially. So an example of what this looks like would be our client who has done the DNS request and requested the IP to talk to google.com, says to Google servers, "Hi, I support encryption and I want to talk to google.com." And Google says, "Hi, here's my cert. Let's do some encryption." And the client says, "Thanks, Google. Let's do it." And then the client turns around in the HTTP request, which is encrypted, and says, "I'd actually like to talk to mything.appspot.com over here on Google App Engine." And Google goes, "Oh, okay, yeah, I know where that is. Here, let me get you the right everything." So doing this by hand is an absolute pain. Would not recommend. Fortunately, the answer to that question is no, we don't need to write something. Already exists. There's a Chrome/Firefox extension called Meek, and I realized earlier today that it also works for the Tor browser within the Tor browser bundle, you know. So you can do that too. There's the URL for it. And what this is you have this client application written in Go, I believe, that runs on your computer, and you give it the extension, the browser extension that you're going to use, the domain that you'd like to front to. So in our example, .google.com, the real destination that you want to go to, so your mything.appspot.com. And it sets up the server, gets set up on App Engine or in some other content delivery network. You can do it with Amazon Web Services as well, if that's what you prefer. And it's worth noting that those services are fairly cheap. I think it's like 5 cents for an hour on Google App Engine, if you're below a certain threshold of traffic. And what that server does is it acts kind of like a proxy. So you're able to send your traffic domain fronted to that server, and it'll forward it on to the right place and make it nice and easy to keep your server name indication information out of reach of your ISP. So, in summary, I realize I've been talking very fast and I'm actually done very early. But SNI was created to solve a very important problem. The problem of needing to be able to figure out what cert you needed to use at the beginning of a TLS conversation, so that servers could host multiple sites. And this is kind of a trade-off between privacy and scalability. Yes, you have what site you're talking to is being displayed, but again, this is how you get multiple sites on the same hosting service. It does leak the subdomain that you're going to of whatever domain you want, but it's not leaking everything after that .com or .org. The rest of the URL is inside that HTTP request. So some takeaways. Should I be worried? Well, it depends on where you live. If you're in a country that's doing censorship or where your ISP may be monitoring you, it might be worth looking into Meek. And it depends on your tinfoil hat coefficient. It really depends on how paranoid you're feeling. So the lesson here is, yes, this leaks information, but we can use this new technique of domain fronting to circumvent some kinds of censorship as part of a bigger anti-censorship setup. And that's all I've got. I did not time that when I was practicing it. I probably should have. But any questions?
So there's really no way to win, though, without you doing domain fronting, though?
Yeah, it's a bit of it takes a bit of effort to set that up, which kind of sucks, but yeah. And it also depends very highly on how much you trust Google and Amazon and those content distribution networks. Yeah.
Now that's really fun for the ISP with that new bill that got, well, not new bill, but the bill that got repealed recently.
Yeah.
So.
Oh, it's that. Which?
Has Trump actually signed that one yet? Yes. He did?
Was that last week?
Yeah. Mhm. Yeah, I'm a little salty about that, but
I would imagine most people would.
yeah, I would hope so.
Well, everyone did call their congressman, right? I did.
Yeah.
I know we did.
We did. Yeah. Watch for the Electronic Frontier Foundation. If you don't know who they are, look them up. I actually follow them on Twitter so I can stay up to date with what bills are getting passed that could possibly cause these sorts of issues. Yeah, I highly recommend following them for updates. They even have a handy, they have a web application that actually lets you call your congressman and it'll like forward the call to you somehow.
Yeah, you put in your phone number and then it rings.
Yeah.
On the other line.
Yeah. Mhm. Yeah, but that way you don't even have to know who your congressman is for for your area. You just tell them where you're at, and yeah. So, does anyone have ideas of how maybe SNI could be improved? I think that's something interesting that we can all think about. Because how do you fix that privacy issue without removing the ability to have multiple sites at the same IP?
Maybe if you turned domain fronting into like a mainstream practice so that your server would have one domain name, so you'd have a bunch of sites that, well, that kind of fails. Never mind.
Yeah,
Doesn't work.
yeah.
You need
It's
for
messy.
that, yeah.
It's messy.
Because crypto.
Yeah, because crypto, exactly.
You know that you need to have the cert before you can actually start talking.
Yeah, you almost have to have like some kind of, I don't know, you almost have to have one handshake first and then do another handshake.
Yeah.
I don't know how you solve that without just doing an overhaul on TLS or something, which nobody wants to do because that's crypto, and who wants to muck with that? Well, yeah, Alex, but yeah. All right. That's all I've got. So